The human desire to create even bigger, ever bigger and more impressive structure is insatiable. Okay, so that means the human desire to create a bigger and a more impressive structure is something which cannot be satisfied. Okay, the pyramids of ancient Egypt, the Great Wall of China, the Burj Khalifa in Dubai are a consequence of pushing engineering to its limit. But huge buildings aren't just monuments to human ambition, they might hold the key to humans' progress in the spacefaring age. So this is an important line, okay? So the author is saying that the if constantly that this constant desire of creating something bigger, something impressive, okay? So it is not just about human ambition, okay? It is something beyond that, okay? And that could be that thing of creating a huge building could actually hold the key to humanity's progress in the spacefaring age. Proposals are now circulating for a freestanding tower or space elevator that could reach up into the geosynchronous orbit, okay, around the Earth. Such a tower would be an alternative to rocket-based transport and drastically reduce the amount of energy it takes to get into space. Okay, so you know that we will gonna read in the further paragraphs about the space elevators and all that. Okay, so human have always built large buildings and quickly get into human progress in this space. Okay, so tower from a ground to a geosynchronetic so where is this geosynchronetic, okay, orbit, space travel would become cheaper in terms of the energy it takes. Okay, so in case if I have to give you the keywords, okay, or in case if I have to give you the note of this paragraph, I would say, let's say the space elevator, okay, and something the future of spacefaring, okay, can hold the key to reduce the energy it takes to get into space. Okay, so in recent years, engineers have managed to build on grander scales thanks to the strength and reliability of substances such as novel steel alloys. But as we enter the realm of mega structures, those of 1000 kilometer or more in dimension, maintaining structural integrity will become a finest challenge for structures made of any material presently available, because bigger something becomes, the more stress it experiences due to its own weight and shape. Okay, so currently let's say we have a particular size, okay, we can create a building of a particular size, okay, but anything mega structures, okay, which is those of 1000 kilometer or more in dimension, okay, no existing material can be used because of that, because of its because there is a certain weight that they can take. Okay, there's a certain stress. So stress is a measure of mechanical tension, like when you pull something apart from either end or squeeze it together. Strength is the maximum tension a structure can withstand before it takes it further explaining us. Okay, so again, building, maybe what could be the takeaway from this particular paragraph is that building mega structure is very challenging, okay, using the currently available material because of the load bearing capacities. Okay, so in recent years, engineers have managed to build on grander scale thanks to the strength and reliability of substances. But as we enter the realm of mega structure, those of 1000 kilometer or more in dimension, maintaining structural integrity will become a finest challenge for structure made of any material presently available, because the bigger something becomes, the more stress. Okay, so it turns out that biological design, okay, equipped with around 3.8 billion years of experience might I'm so sorry, might help solve this puzzle. Before the age of material science, engineers had to find their solutions in nature, okay? Wood, leather, stone, weaker metals that could have been cast through melting in iron, that could also be beaten into shape, okay? But then substances such as steel and concrete arrived and become successively tougher and lighter, allowing designers to make structures that were much stronger than the maximum possible. So allowing designers to make structures that were much stronger than the maximum possible load they need to bear. However, once structure turns into the mega structure, this risk averse places a cap on their side. So an important paragraph, okay. So what the author is saying here, okay, that initially we used to turn to nature to find the solutions of the problem, okay, and the biological design, okay, that is how our body actually works, okay. I'm so sorry. This can serve as a foundation, okay. This can give you the hint about how you can build the mega structures. Okay, so he's saying that um, allowing designers to make structures that are much stronger than the maximum load they need to bear. Okay, so maybe let's say there is a load building capacity of a building is X. Okay, so engineers or the designers right now are in a position to build something which can take, let's say, 5x, 4x, 3x, 2x, or 1x. Okay, so allowing designer to make structures they were much stronger than the maximum possible load they need to bear. However, once structure turns into mega structure, this risk averse approach places a cap on their size. Now, what is this risk averse approach? Okay, so suppose because of steel and concrete, okay, now the engineers and designers could build structures that could bear 1,000 metric tons. Okay, but they can go for the mega structures. Okay, however, once structures turn into mega structure, this risk averse approach, okay, so this risk averse approach is actually keeping the buffer. Okay, so what is a buffer? That is, I'm building a building which can take X as a capacity, but I'm keeping it a buffer capacity of a 5x. Okay, but now in the case of this mega structures, okay, the scientists actually cannot keep this kind of a buffer. Okay, because the building itself is a 1,000, okay, a 1,000 kilometer or more in dimension. So you cannot make it in a 2x form or all that because of the current material that is available. Okay, so that is what the author actually needs to say here in this passage. Okay, however, neither the bones nor the tendons in the where is the cursor? Yeah. However, neither the bones nor tendons in our body enjoy the luxury of being capable of carrying more than the maximum possible burden. In fact, they are often compressed and stretched well beyond the point at which their underlying substances begin to break. That is why our body constantly repair and recycle their materials. Okay. For example, collagen fibers in tendons are replaced in such a way while some remain damaged, the overall tendon is safe. This constant self-repair is efficient and inexpensive and can change based on the load. Okay, so now what the author is saying that in case if you have to build something which is mega structure and all that, okay, you need to take the help from a biological design. Okay, so for example, the biological design with their self repair capacities can give us clue, okay, on how to build mega structures, okay, that can carry more than the maximum possible load they can actually bear. Okay, so it's saying that body is not actually meant for double or triple. Okay, double or triple the amount of burden that they can actually carry. Okay, so they usually operate at a low level. Okay, but they have this system of constantly repair and recycling their materials. Okay, so it's better that you create a mega structure based on a biological design, that is you keep this which has this self repair capabilities. Okay, that can carry more than the maximum possible load they can actually bear. Recently, this self-repair paradigm, okay, now what is this self-repair paradigm? That is actually a biological design paradigm, okay, was applied to a possible model of reliable space elevators with available materials, okay. One proposed design features a 91,000 kilometer long cable called the tether, extending out from the equator and balanced by a counterweight in space. The tether would consist of bundles of parallel fibers similar to collagen fibers in tendons or osteons in bones, but made from Kevlar, a material used to manufacture bulletproof vests. Using sensors and artificial intelligence, it would be possible to predict when, where, and how the fibers would break. Okay, so this kind of a thing, like a self-repair mechanism that the body has. Okay, so constantly repair and recycle their materials. So they say that this self-repair paradigm was actually applied to a model of a reliable space elevator with the available materials. Okay, and they have this biological design of constantly repairing and recycling. Okay, so they use the sensors and artificial intelligence for this purpose. And when they do, speedy robotic climbers patrolling up and down the tether will replace them, adjusting the rate of maintenance and repair as needed. Despite operating at a very high stress compared to what materials can sustain, we showed this structure would be reliable and would not demand exorbitant rates of replacement. Moreover, the maximum strength the material needs to possess to achieve a dependable structure was cut by 44%. Okay, so overall on, in case if I have to summarize this passage, I would say that using the body self-repair paradigm, okay, it can be possible to build a space elevator with materials having much more lower strength, but that has the sensors and an artificial intelligence which is working on constantly repairing and recycling the material. Okay, so overall, I would say a moderate passage. Okay, I would not rate it as a very easy passage to be read. Okay, because there is some kind of a complexity, but not that too difficult that you're not able to figure it out. Okay, so let's actually move to the question types. Okay, so according to the passage, the application of self-repair paradigm will. Okay, so the self-repairing paradigm was mentioned here, and what is the self-repair paradigm? Okay, so it is like a biological design. Okay. A biological device design, okay, converts, so the application of self-design paradigm will convert space elevators into biological system. Is it even possible? Can the the space elevators can be converted into biological system? Okay, biological system are actually a natural living system. Okay, so a space elevator cannot become one. Okay, it cannot become a human being, it cannot become a living structure. Okay, the passage talks about mimicking the biological system. Okay, so the passage is saying that whatever the biological design is there, okay, you can use that particular mechanism of their self repair or self repair and recycle. You can use that, okay, why for building the space elevators, but convert space elevators into biological system is next to impossible. Okay, make mega structures possible with available materials. Now this is an easy question and this is actually the correct answer. Okay, see, there is a line which returns here. Okay, so recently this self paradigm was applied to a possible model of reliable self space elevators with available materials. Okay, so make mega structure, because you know that the space elevator is a mega structure that the author is talking about. So the application of the self paradigm will make mega structure possible with available material, because recently this self repair paradigm was applied to a possible metal or model of all reliable space elevators with available material. Okay, so it eliminates the need for creating, let's say, new materials for mega structures like space art elevators, and that's the correct answer. But anyhow, let's see the other option also. Will allow use of collagen fibers in space elevators. Again, is it even possible? Collagen fibers are the natural proteins which are found in the connective tissues. Okay, space elevators will use the artificial materials. Okay, and they have mentioned the name also. Okay, so they said, okay, Kevlar. Okay, so which is kind of equivalent to your this you would say it is equivalent to the collagen fibers, similar to the collagen fibers in tendons or osteons in bones, but made from Kevlar. Okay, so you cannot use the collagen fibers in the space elevators because that is something which is a part of a biological body. Okay, so you cannot take it out and put it in the space elevator. So not a correct answer. Will eliminate the need for repair of mega structures. Now, this was again one of the close by option which could have definitely troubled you. Okay, so it will eliminate the need for repair of mega structures. Okay, so it will not eliminate the need for repair. Okay, but would demand exorbitant rates of replacement. Okay, so what is this saying? Okay, so it is saying that we need to actually turn to the biological design that is actually constantly repairing and recycling their materials. Okay, and this repair and recycling of the materials, okay, should actually be used when you're actually building a space elevators or the mega structure. See, there they mention, okay, extending out equator. Okay, material used to manufacture using sensors and artificial intelligence, it would be possible to predict when, where, and how the fibers would break, and when they do, speedy robotic climbers patrolling up and down the tether will replace them. Okay, so will eliminate the need for repair of mega structures. It will not eliminate the need for repair of mega structures. Okay, but it would rather demand the rates of replacement. Okay, and in fact repairing it constantly is actually the application of a self-repair paradigm is there in the process. So repair is constantly going to happen. Okay, self-repair is actually factored in when we talk about the building of a mega structure based on the application of a self-repair paradigm. So that's the reason that the second is the correct answer. I hope you got it correct. Okay, now in the first paragraph the author considers the concept of space elevator chiefly as, okay, So we need to focus upon the first paragraph because the author is being kind to us and he's giving us the passage paragraphs that we need to focus on. So in the first paragraph, the author considers the concept of space elevator chiefly as, okay. So where is the space elevator is here, okay. So let's see. The human desire, okay, but huge buildings aren't just monuments to human ambition. They might hold the key to humanity's progress in the spacefaring age. Proposals are now circulating for a freestanding tower or space elevator that could reach up into geosynchronous orbit around the Earth. Such a tower would be an alternative to rocket-based transport and drastically reduce the amount of energy it takes to get into space. Okay. So in the first paragraph, the author considers the concept of space elevators chiefly as a symbol of human progress in the space age. Okay. Is it the symbol of human progress? Okay. In the space age, what the author is saying is that huge buildings aren't just monuments to, they might hold the key to humanity's progress in the spacefaring age. Okay. So what the author is saying that they might hold the key to humanity's progress. Okay. But holding the key is not equivalent to symbol. Okay. See, holding the key means to have, let's say, control over it or to make something possible by providing a solution or explanation. Okay. But it does not suggest that any of the mentioned structures are a symbol. Okay. The passage is clear about that the space elevator is holding the key to spacefaring age. Okay. And holding the key is not the same as symbolizing. Okay. Only the key unlocks. Okay. And only the key unlocks and we find the solution. Okay. It becomes a solution. Okay. It becomes a symbol, sorry. Okay. So a symbol of human progress in the spaces. So once we are able to figure out the solution, then we can say that it becomes a symbol of human progress in the space age. But right now it is not the symbol, but it is just holding the key to humanity's progress in the spacefaring age. Okay. It's not a symbol. Okay. Once we know, okay, that this is the solution. Okay. This is how we can build the monuments. Okay. This is the thing. Okay. Then we can say that particular solution to be the symbol. Okay. But right now we're not pretty sure. We cannot say that this is a symbol of human progress in the space age. Okay. So when we say, let's say, Mahatma Gandhi was a symbol of a freedom. Okay. So because he provided us the solution of the freedom. Okay. In case we hold the key, okay, he does not have a concrete solution, but he can give you a possible solution. That time he does not become a symbol. Okay. So that is the reason that the first is not the correct answer. Okay. And easier in the first paragraph, the author considers the concept of space elevator chiefly as an easier mode of transportation to space and back. Okay. Now this is actually the correct answer. Okay. Now is easier. He says the space elevators as an easier mode of transportation to space and back. Okay. So let's say they might hold the key to humanity's progress in the spacefaring age. Okay. Perhaps are now circulating for a free-standing car or space elevator that could reach up to geosynchronous orbit around the Earth. Such a tower would be an alternative to rocket-based transport and drastically reduce the amount of energy it takes to get into space. So an easier mode of transportation, okay, to space and back. Okay, so it will be an easier mode of transportation in terms of cost, in terms of pocket, in terms of energy. Okay, so that is the correct answer. But let's see the other option. A representation of human desire for huge and impressive structure. Now this is incorrect. Okay. Why this is incorrect? Because the author is saying that but huge buildings. Okay, just a second. Okay. Because the author is saying that huge buildings aren't just monuments to human ambition. They might hold the key to humanity's progress in the spacefaring age. Okay. So it's not just the representation of a human desire, but there's something else. Okay. So that is not the case. Space age equivalent of the pyramids, the Great Wall of China, and the Burj Khalifa. No, okay. He mentioned all these buildings, okay, to say that the human desire to create something big and pushing engineer to its limit. But again, these huge buildings aren't just monuments to human ambition. So the author does not consider the concept of space elevator chiefly as a space age equivalence of the pyramids. Okay, he's saying that it is beyond all these things. Okay, now out of the 1 and a 2 option, I've already told you that why it cannot be the symbol. So the left option by the option elimination is the second. That is an easy, and the author considers the concept of space elevator chiefly as an easier mode of transportation to space and back. Okay, so easier because it will going to be an alternative to the rocket based transport and it will going to reduce the amount of energy. Okay, and you can reach up into the geosynchronous orbit around the world. Okay, around the Earth. So that's the reason that it is an easier mode of transportation to space and back. Okay. Now, a space elevator is currently not possible to build because, so we know, okay, that a space elevator is not built because of the available material. So we have read this in the paragraph, but let's read the option, okay. So there is no see second paragraph, it's written in recent in years, okay, engineers have managed to build on grander scales, okay, thanks to the strength and reliability of substances such as novel steel alloys. But as we enter the realm of mega structures, so mega structures is a space elevator, those of 1000 kilometer or more in dimension, maintaining structural in the integrity will become a fiendish challenge for structure made of any material presently available, because the bigger something becomes, the more stress it experiences due to its own weight and shape, okay. So a space elevator is currently not possible to build because there is no engineering design available for a space elevator, okay. So nowhere does the author is saying that there is no engineering design or something, okay. In fact, the last paragraph says that there was a line, okay, one proposed design, okay, features a 91,000 kilometer cable, okay, called a tether, extending out from the equator and balanced by a counterweight in space, okay. So there is a one proposed design, okay. So there is no engineering design available for a space elevator is actually factually incorrect, okay. Such a structure would collapse under its own weight and shape, okay. Now can you see how this option is being framed, okay. The question is that why a space elevator is not currently possible to build, okay. And this is telling us that the reason could be it is not we don't have a suitable materials available, okay. So if you build a structure, it would collapse. If you build a structure with the available material, it would collapse under its own weight and shape, okay. So this is actually the effect, okay. This is not telling us the cause, okay, that why the question is asking you the cause, that why space elevator is currently not possible to build, okay, because we don't have the current material, okay, or the material which is presently available is not sufficient to carry more stress, okay. So that is the reason, okay. And in case if we build it with a current available material, it will collapse under its own weights and shape, okay. So this is a kind of an effect, okay, but it is not telling us the cause, okay. So maybe one of the reason that you feel that this could be the answer, but again there's a problem with the cause and effect, okay. Now mega structures of 1000 or kilometers or more in dimension cannot be built, okay. Again this is kind of a, let's say, a restatement of the question, okay. So the question is why they cannot be built, so this statement is also telling us that they cannot be built, okay. Now the question is asking you why they cannot be built. The question itself knows that the space elevator is currently not possible to build. So the mega structure of 1000 kilometers or more in dimension cannot be built. But it is not answering the question, okay? It is just kind of, let's say, this option is repeating the question. The question is why they cannot be built, okay? So by the option elimination, we know that the fourth is the correct answer. So there is no suitable material available for structures, okay? So the passage is discussing in this second paragraph, the passage is discussing the paucity of a suitable material, okay. Hence design to has to be different, okay, because the presently available material, okay, it cannot handle the more stress, okay, due to its own weight and shape. So that is the reason that the space elevator is currently not possible to be built, okay. Let's get into the, I hope you are able to understand these questions, okay. So as per the passage, why is the current design paradigm, okay, so current design paradigm unusable to build the space elevator, okay. Now what is this current design paradigm, we need to understand, okay. So para 3 and 4, okay, this explains that how the biological system, okay, work, okay, and repair themselves for the damage suffered during the functioning, okay. So this is how, and this self repair paradigm we should apply to the possible model of a space elevator, okay. And this question is asking why is the current design paradigm, so current design paradigm is whatever you are using to build the huge monuments now, okay, that is not based on a biological design, okay. So it is unusable to build space elevators, okay. So there's a line, okay, but then substances such as steel and concrete arrived and become successively tougher and lighter, allowing designers to make structures that were much stronger than the maximum possible load they need to bear However, once structure turns into mega structure, okay, this risk averse approach places a cap on their size. Okay, so that is the reason that the current design paradigm, which is actually based on your this alloy of this steel and concrete, okay, this is not possible, okay, because it is possible because let's say successively for alloy design to make structures that were much stronger than the maximum possible load than KPR. Okay, so steel and concrete, let's say you have to build a building which carries the load of X. Okay, so with the steel and concrete, you can build something which is 5X, okay, 4X, 3X, whatever. Okay, but however, one structure turns into mega structure, this risk averse approach. Okay, so this risk averse approach is actually the approach of keeping a buffer. Okay, places a cap on their size. So in case if you have to build something above 1000 kilometers, so it is not possible you to build something which is 2x. Okay, so because it places a cap, it's not possible, okay, with this kind of the material. Okay, so that is a case that current design paradigm, okay, why is unusable to build space a structure because it's risk averse, thus placing a cap on size. Okay, so it's risk averse and places a cap on their size. So a direct line which is kind of mentioned here. Okay, I think so that you might have got little bit problem here in finding out what is the current design paradigm actually stands for. Okay, so current design paradigm, you can say it's actually the risk averse approach of the designers to make structures that were much stronger than the maximum possible load they need to bear. Okay, but whereas in case of a mega structure, which already carries too much of this, which carry much more than the permissible burden, it's not possible to build something which is 2x or something like that. Okay, so that is actually the correct answer. Okay, so again, with the current materials, the engineer designers can't build a structure which is beyond a particular size. Okay, so the current design paradigm is risk averse because engineers are aware that it is suitable for megas, it is not suitable for mega structure. So that is the reason that it places a cap on their size. Okay, so this option, it's risk averse, thus placing a cap on size. This implies that the cap on their size makes them unfit for mega structure. Okay, so this risk averse approach, which is actually the approach of carrying the overcapacity, is not possible when it comes to building the space elevators. Okay, now it caters to showcasing human ambition and not progress. No, this is not the correct answer. Okay, this, first of all, this option does not address the issue of the usability or the unusability of a current design paradigm. Okay, current design paradigm to build space elevators. Okay, and secondly, it is already saying that these huge buildings aren't just monument to human ambition, but they are something else. Okay, now it caters to building modern pyramids but not spacefaring. Now nowhere does the author or the passage anywhere mentions the modern pyramids. Okay, so the modern pyramids is totally irrelevant to the passage and to this particular question. Okay, it cannot handle complexity. Okay, this again, this is a tricky option. Okay, this might have troubled you that as per the passage, why is the current design parameter unusable to build space elevators? Because it cannot handle complexity. Okay, but the fact that a biological mega structure don't exist in nature in itself. Okay, you can again this complexity, it cannot handle the complexity. Okay, uh, it's there that it cannot handle the complexity. And see, complexity again, I would say, first of all, it is not being mentioned. Okay, it is nowhere mentioned that it cannot handle the complexity. The current design paradigm cannot handle the complexity. Okay, what it cannot handle is actually the risk averse approach. Okay, so this, the risk averse approach which they use it for the current buildings and all that, this won't be possible when you're actually building the mega structure. Okay, but whether it can handle a complexity or it cannot handle the complexity, it's a far-fetched inference. Okay, which is, there is no direct line. Okay, so it cannot handle complexity for what? Okay, so that is something which is not directly mentioned in the passage. Okay, so that's the reason that fourth is not the correct answer. Okay, so let's get into it. So I mean, like, again, this option, this question was a slightly tricky. Okay, and it's a good question. Okay, it's a very good question rather. So again, it's okay. Okay, you need to develop this skill of elimination sometimes. Okay, in case if you're not able to understand this line and all that. Okay, what is the places on cap on the side? So again, with the risk, sorry, again with this option elimination. Okay, this could have been done. Okay, so now the last question, the fifth question for this particular passage. Okay, so recently this self-repair paradigm, so okay, so there's a line. Okay, was applied to a possible model of reliable space elevator with available materials. Okay, which of the following is most crucial for the success of the proposed model? Okay, so let's see. Okay, so the whole model is actually built on this self-repair. Okay, so what is this? Simply this self-repair paradigm. Okay, now what is this self-repair paradigm? That is actually similar to the biological design. Okay, in which we put this principle of constantly repair and recycling their material. Okay, so this self-repair paradigm, okay, was applied to a possible model of reliable space elevators with available materials. One proposed design features a 91,000 kilometer long cable extending out. Okay, the tether would consist of bundles of parallel fibers similar to collagen fibers in tendons or osteons, but made from Kevlar, a material used to manufacture. Using sensors and artificial intelligence, it would be possible to predict when, where, and how the fibers break, and when they do, speedy robotic climbers patrolling up and down the tether will replace them, adjusting the rate of maintenance and repair as needed. Okay, so as to what materials can sustain. Okay, so we know that it is actually the repair and the recycle mechanism, okay, which is the integral part of the self repair paradigm. So any option which is talking about this kind of a thing is actually will be the answer. Okay, so the autonomous, the self, okay, so autonomous is the self. Okay, so this self repair and replacement mechanism, okay, which is being done through sensors, artificial intelligence, and then robots. Okay, so that is actually the most crucial for the success of the proposed model. Okay, so there are no details in the mechanism, except there is a mechanism. Okay, besides the passage states that there is an we need to look to the biological system. Okay, and biological system says that we need to constantly repair and recycle the material, and this constant repair and recycle material was an integral part of the self repair paradigm. Okay, so we can build with the available materials, but in case if there is too much of a load and all that, we can always have a system of a self repair. Okay, self repair and replacement. Okay, which can be done by the robotic climbers, sensors, and the artificial intelligence. So this is the most crucial for the success of the proposed material. Okay, the material to be used for the bundles of the parallel fibers. Okay, now the material, it is sufficiently addressed. Okay, so it's written, even the material is mentioned that it is the Kevlar. Okay, so material to be used for the bundles of parallel fibers, that is actually the tether would consist of bundles of parallel fibers similar to collagen fibers, but made from Kevlar. Okay, so the material to be used for the bundles of parallel fiber is not the most crucial for the success of the proposed model. Okay, the stability of 91,000 kilometers stretching to the space. Okay, the stability is explained. Okay, it's mentioned here. Okay, that one proposed design feature a 91,000 kilometers long cable extending out. Okay, so that is there. Okay, the stability of 91,000 kilometer is not actually the crucial. Okay, the strength of the tether that might break under its own weight. Okay, so they are saying that there's a line, no, despite operating, I did just right now. Okay, so despite operating at a very high stress compared to what materials can sustain, we showed this structure would be reliable and would not demand exorbitant rates of replacement. Moreover, the maximum strength of the material would need to possess to achieve a dependable structure was cut by 44%. Okay, so see all these options. Okay, they're not crucial. Okay, why they're not crucial? Because they were crucial before this self-repair mechanism. Okay, so before this self-repair mechanism, the material was crucial. Okay, the strength of the material was crucial. Okay, but once we have employed this after self-repair mechanism, okay, this is not important, this is irrelevant. Okay, because we are building it with the available material, so the available material is not important. Okay, the strength of the available material is not important, but what is important, what are we learned from the self repair mechanism of the biological design is actually the repair and the recycle or the replacement. Okay, so this part becomes more important. Okay, because in case if we are using it with the available material also, we know that the strength is less. Okay, we know that they cannot carry that kind of load. Okay, but to repair that, we have this repair and self repair mechanism. Okay, so this is most crucial. That's autonomous repair and the replacement mechanism is most crucial for the success of the proposed model, not all these things. Okay, so that is the reason that the first is the correct answer. Okay, so overall, a moderate passage, I would not rate it as a pretty easy passage, but still I hope that with your current understanding and with the amount of the practice, you are able to solve a good amount of the questions here. Okay,